Hey there, let's take a look at binary and think about how we can turn binary into other pieces of information, in particular text. So let's start with a real simple binary value. How about, and let me give myself a pretty big paintbrush so that you can actually see what I am writing here. So let's take the number 0, 1, 0, 1, 1, 0, 1, 0. So let me take one that's not so smudgy. If we translate this into a decimal number, what we have to do first is take base 2 to each of the exponents. So this first column is 2 to the 0, or the 1's column. This is 2 to the 1, the 2's column, 2 to the 2, the 4's column, and we can go on. So we have 8, 16, 32, 64, and 128. Now we have 0 128s. We have 164, so I'm going to write 64 down here. We have 0 32s. We have 116. I'll write 16 down here. And we are now up to 80. We have 1 8, so we now have 88. We have 0 4s. We have 1 2, so we are up to 90. So this binary set of numbers 0 1 0 1 1 0 1 0 really equals the decimal number 90. All right, well, that's all well and good, except what if I don't want a number? What if I'm trying to create a letter, like a letter in the alphabet? I still can only put binary onto a computer. At the end of the day, we're storing electrical signals or magnetic signals. So how do I get the number 90 to turn into a letter? Well, the answer lies in using a table or a way to translate that into that binary into some other language. And we need some way to translate that. So we use a standard called the ASCII table, which I'm going to bring up right now. So here is the ASCII table. And essentially what it does is it takes decimal numbers, that's what the DEC stands for, decimal numbers from 0 up until 127, and translates them, or really just lines them up with some predetermined value. So for example, if we go through the decimal numbers up to 90, we see that 90, it has the character value of Z, which means if we take the binary, the 8 digits of binary that represent the number 90, but tell the computer, don't treat this like a number, treat it like a letter, it'll give us the letter Z. So let's test that and make sure it works. Now, I'm going to use NetBeans as my IDE, and I'm going to be working in Java programming language. This is pretty much true of any programming language. So let's do a quick test right off the bat. We're going to do system.out.println, and let's just write hello, just to make sure that we can see something. It's always good not to make an assumption that your program works when you haven't tested it yet. And I think on this file, let's see, okay, so we got hello down there. And let me actually adjust my font size so it's a little easier to see, because I know the screen might be a little small. All right, hopefully that makes it a little bit better. And we'll bring the output back out as well. So instead of printing the word hello, let's create a variable. And we're going to create an int variable. So int stands for integer. And we'll just call this num, and we'll make it equal to the number 90. Well, if we print out, or tell the computer to print out num, we're going to get 90. We've told it is a integer. We've given it an integer value, and it prints an integer value. There's our 90. If we were to create a character instead, a char, and let's call it last let for last letter, and make that equal to Z. I don't want to make it a capital Z, actually, just to be consistent. And instead of printing num, we say print last let. We should see a Z. So let's do that, and we'll run that. There's our Z. But we know that the binary for both of these is really the same. So at the end of the day, we go back to this screen, a Z in memory is 0, 1, 0, 1, 1, 0, 1, 0, and a 90 is 0, 1, 0, 1, 1, 0, 1, 9, 1, 0. The only difference is this area in front of it. This area in front of it that we can use to identify how to translate the next set of zeros and ones. So in Java, and again, a lot of other programming language, we can do something called casting, where we say, I have some binary, it's stored as a particular type of variable, but I'd like you to treat it differently. So you can think of the word casting like the cast in a movie or the cast in a play. We know when Brad Pitt plays a character, he's pretending to be that character. He doesn't become someone else. He's still Brad Pitt. He's just pretending to be that other person. So we can say, I have num, and num is an integer. It is a number, but I want to treat it differently for a moment in time. So let's go back to printing num. And again, just to make sure that it still works, we should get 90. There it is. And now what we're going to do is cast it. We're going to say, hey, num, I know you are the number 90, but what I'd like you to do is treat yourself like a character, a letter in an alphabet right now. And because that's not really a violation, it's okay to have a person pretend to be another person. You couldn't ask Brad Pitt to play an airplane, for example. He's not an airplane, he's a human. And you couldn't say, take this toaster and treat it like a car and get it and drive it around. So you can't cast any one item to be another. But integer numbers can be treated like characters because we know they have the same underlying meaning. And we also know that the ASCII table tells us directly that all of these standard characters in our alphabet are really just numbers that are pretending to be, that are acting like letters for the purpose of, letting us put together words and have other sets of symbols to work with as we build more sophisticated programs. So we have a number, 90, and we're treating it like a character. So now when we print, we see that letter Z. We just took that same set, zeros and ones, and said, act like you are a character, and it changed what was in front. It said, instead of treating it like a number here, it said, treat it like a character. So we just said, interpret these zeros and ones differently. Now, this can also work in reverse. So let's do another print statement, system.out. Print line, and we are going to take the last letter of the alphabet, which we know is a Z, but we're going to say treat it like it's an integer. All right, and to do a cast in Java, you just put the type you want to use in parentheses and in front of the variable that you're using. So if we run this now, we see Z and then 90, even though we said print the number first and the letter second. So that is a brief introduction to casting, but also a brief introduction to this ASCII table, which again is just a translation from number to symbol so that we have a way of using symbols in our programs. There's a mathematical way of translating binary into decimal. There is no mathematical way of translating binary into letters. We need to have a table like this that just matches up one letter to one number so that we can make those translations. So I hope that clarifies the purpose of the ASCII table and also shows you a little bit about casting. And again, we did this just in the Java language, but if you Google how to cast in Python or JavaScript or any other language, it's going to be very, very similar, work more or less the same way. All right, thanks for watching. Bye now.